Hello, ladies and gentlemen. Welcome to the Math 12R screencast for continuity and discontinuity. So we're going to be looking at determining whether a function is continuous or not. And we're going to be doing that for a day or two using the graph. So if we look at the definition of continuous, so a function is said to be continuous at a particular value of x if, when you approach from the right side, going left, that value, that limit, is the same as approaching it from the left going right. And that's the same as evaluating the function for that particular value of x. So let's take a look at a little bit of some information here. So for each point on the graph, you need to find the limit and the function value at that point. If they're all equal, the function is said to be continuous at that value of x. If they're not equal, the function is not continuous at that point. So if we take a look at this function, as a piecewise function, we're looking to determine if this is continuous at x equals negative 7. So x equals negative 7 is right here where that dot is. So as I approach x is negative 7 coming from the right, just follow the cursor, my limit is 3. When I approach x equals negative 7 from the left, my limit is 3. If I evaluate f of negative 7, I have that dot, that closed circle, at 3 as well. That means that this function is continuous at x equals negative 7. So I jot these little notes down here. The limit from the left is 3, the limit from the right is 3, and f of negative 7 is also 3. When they all match, the function is said to be continuous at that point. So now let's continue and take a look and see if this function is continuous at negative 2. So here's negative 2, this line right here. Follow the cursor. So as I approach x is negative 2 from the right, my limit is 3. When I approach x is negative 2 from the left, my limit is 3. But if I evaluate f of negative 2, I have an open circle and a closed circle. So f of negative 2 is 1. Since they all don't match, the function is not continuous at negative 2. Well, let's find out if we're continuous at x equals 2. As you approach from the right, follow the cursor, the limit is negative 3. When I approach x equals 2 from the left, the limit is 0. Since they already don't match, the function is discontinuous at x equals 2. And if I ask you to evaluate f of 2, it's going to be negative 3. All of these have to all match for the function to be continuous at that value. So if you look at A, approaching from the left, approaching from the right, and evaluating f of negative 7, all yields the same answer of 3. So this is continuous at x equals negative 7. When we evaluated x equals negative 2, approaching the function from the left and the right gives you a value, a limit of 3. But f of negative 2 is 2. No, it's 1. There's a typo. So that's going to be 1. So f of negative 2 is 1. So therefore, the function is not continuous. Let's take a look here. If there's a hole in the graph, the function is not continuous at that value. Now the question that I'd like everybody to think about so you can answer in class is what causes that hole in the function? This hole, that hole, the ones I'm pointing to with the cursor. What causes those holes in the function? It's something we've talked about. So think about that, and we'll talk about that in class. So let's look at another example. We're going to look at the graph on the right, and we're going to evaluate if we're continuous or discontinuous at different values of x. So let's start with the first one, part A. Are we continuous at x equals negative 7? Well, when I approach x equals negative 7 from the right, it's negative 3, the limit. When I approach x equals negative 7 from the left, the limit is still negative 3. But when I evaluate f of negative 7, my closed circle is at 0. So this function is not continuous at x equals negative 7. Now let's take a look at x equals negative 3. As I approach negative 3 coming from the right, my limit will be 6. As I approach x equals negative 3 from the left, my limit will be negative 1. But when I evaluate f of negative 3, the answer is going to be 6. So they don't match. Therefore, we are not continuous at x equals negative 3. What I'd like you to do now is complete parts C and D, and we'll go over those in class. So again, when you're trying to find out if a function is continuous or discontinuous at a particular value of x, we do what we did when we first started looking at limits. You track from the right-hand side, you track from the left-hand side, and then you look for either a line or a closed circle. The open circle does not have any bearing on it. Okay? The open circle is not an evaluation of a function at a particular value. That's the hole in the graph. So, thank you for tuning in. I'll see everybody in class. So, you need to answer the question about what causes a hole in the graph, and you also need to answer parts C and D right here. I'm going to go back and fix that typo. So in the meantime, if you need to replay the screencast, please do so. I'll see everybody in class, and we'll continue on from there.